Today we are going to discuss the learning outcome, understanding the development life cycle of a system, and how the choices we make along the way shape the solution we end up delivering. Over this session, we will work through the main life cycle models and where each one fits. Look at how the context an organization sits in, influences development, and then move into the tools and modeling approaches an architect can call on before finishing with the impact that change requests have on a live project. Before we dive in, let me set out the shape of the session. We will start by comparing the different life cycle models and weighing up their benefits and drawbacks. From there, we look at how the context of a required solution, the organization around it, pushes development in a particular direction. Then we get into the tools, techniques, and modeling approaches an architect chooses, and we close by examining how change requests can ripple through a system's development project. Let's begin with a simple question. Why bother with a life cycle model at all? A systems development life cycle, or SDLC, gives a project a structured route all the way from an initial idea to a delivered, working solution. It sets out the stages you pass through, the deliverables you produce, who is responsible, and the order things happen in. And the model you pick has real consequences. It shapes your cost, your quality, your risk exposure, and how quickly you can deliver, which is exactly why different models suit different levels of requirement stability. The waterfall model is the classic starting point, and it is sequential. You finish one phase completely before the next one begins. You move from requirements into design, then implementation, testing, deployment, and finally maintenance, rather like water flowing down a series of steps. Its strengths are clarity and documentation because every stage is signed off, and it is easy to plan a budget and timeline up front. The catch is that requirements are very hard to change once they have been agreed, and you do not see working software until quite late. So Waterfall really shines when the requirements are well understood and stable. Iterative and spiral models take a different stance, building the system through repeated cycles rather than one single pass. With an iterative approach, you develop a version, review it, and refine it again and again, so early versions can be adjusted, though the scope can balloon if those cycles are not kept under control. The spiral model adds a structured risk analysis to each loop, so before you commit to the next cycle, you deliberately assess the risks. That is powerful for large or uncertain projects, but it can become costly and complex to manage. The V-shaped model is really waterfall folded into a V, and its clever idea is to pair every development phase with a matching test phase. So requirements gathering is linked to acceptance testing, design is linked to system testing, and so on down and back up the V. The benefit is a very strong emphasis on quality assurance, and because each test traces back to a specific requirement, defects are easy to pin down. The downside is that, like Waterfall, it is inflexible when requirements change, and testing only really begins once the coding is largely finished. Agile flips the emphasis towards delivering working software in short iterative increments with constant input from stakeholders. The work is broken into short cycles, often called sprints, and at the end of each one you have something usable to show. That means Agile copes really well with changing or emerging requirements, and frequent feedback cuts down on nasty surprises late in the day. The trade-off is that a fixed cost or end date is harder to pin down, and it demands disciplined communication, otherwise the scope quietly drifts. Two further approaches are worth knowing. DevOps brings development and operations together so that releases become continuous, faster, and more reliable, though it asks for a genuine cultural shift and a lot of automation to work well. Rapid Application Development, or RAD, leans on quick prototyping instead of heavy upfront planning, so you get a working system in front of users fast for feedback. RAD is less suited, though, to large, complex or heavily regulated projects, where that lighter planning starts to become a liability. Let's pull back and weigh up life cycle models in general. On the benefits side, a model gives everyone a shared, repeatable structure. It clarifies who does what and when decisions get made. It improves communication with stakeholders, and it creates natural points to identify risk and to plan cost and time, along with documentation that supports handover. But there are drawbacks too. Applied too rigidly, a model adds overhead. The wrong choice may simply not fit the type of requirement. It can slow your response to legitimate late changes, and it takes discipline and training to apply properly. So what happens if you pick no model at all, or a badly mismatched one? The problems are quite predictable. Communication with stakeholders suffers, which disrupts their whole journey, and it becomes much harder to recover cleanly when something goes wrong. The delivered system often fails to meet the requirements fully, deadlines slip, and costs climb as deliverables get cut or reduced. In the worst case, the project collapses entirely, and with no documentation and no clear ownership of deliverables, there is very little to fall back on. Let's make this concrete. Imagine a retail company that needs a new online return system. The requirements are well defined by finance and operations, and there is a fixed deadline tied to a regulatory change. Here, a waterfall or V-shaped model fits nicely because the requirements are stable and the sequential phases can be planned against that immovable deadline. The V model's formal testing phases are especially handy for verifying the compliance requirements. An agile approach would sit awkwardly here, since it prizes change over a fixed plan, and in this case the plan is exactly what we need to protect. Now we shift from the how to the where, the context a solution is built in. Start with organizational culture and climate. Culture is the deeper set of shared values, norms, and ways of working, while climate is more the current mood, the pressures and priorities right now. A risk-averse culture will lean towards structured, well-documented approaches, whereas a collaborative, innovative one may take happily to iterative or agile working. Ignore culture and climate, and you raise the odds that a perfectly good solution simply is not adopted. A solution should also pull in the same direction as the wider business strategy, not against it. The organization's strategic goals shape what the solution has to prioritize, so you are aligning to the overall direction, not just scratching a local itch. That alignment matters practically too, because it is what helps justify the investment and win executive sponsorship. Get it wrong, and you can end up with something technically excellent but strategically irrelevant, which is a very hard thing to defend. Every solution has stakeholders, and they rarely want exactly the same things. Think of the users, the sponsors paying for it, the operations staff who will run it, and the IT teams who will support it. Their needs have to be gathered, prioritized, and validated, and where those needs conflict, part of the architect's job is to balance and negotiate between them. Keeping stakeholders engaged throughout, rather than just at the start, is one of the surest ways to get the finished solution actually adopted. New solutions almost never start on a blank sheet. There are usually existing business systems that both constrain and inform what you build, and integrating with legacy systems will shape your design and technology choices, whether you like it or not. This is where process thinking helps. Instead of automating isolated tasks, you design around the end-to-end business process. Done well, that reduces duplication and lifts the efficiency of the whole flow, not just one corner of it. It is easy to forget that developing a solution is itself a change, and change has to be managed for people, not only for technology. Change management prepares staff for new ways of working, dealing with communication, training, and the very natural resistance people feel. Skip it, and even a beautifully built system can stall because nobody is ready to use it. The key point is that change management should run alongside the development lifecycle from the beginning rather than being bolted on at the end. Let's tie the context together with an example. A university wants a new student enrollment system. It has a cautious culture, existing legacy student records, and a strategic goal of improving the student experience. That cautious culture points us towards a structured, well-governed lifecycle model. The legacy records cannot simply be thrown away, they will need to be integrated. The strategic goal shapes which stakeholder priorities come first, and because staff will be working in new ways, a solid strand of change management is essential to make it stick. Let's pause and check what has landed so far. Can you name 2 benefits and 2 drawbacks of using a life cycle model? Have a think about what can happen to a project that uses no model at all. Then ask yourself how an organization's culture might steer the choice of development approach and why a solution really needs to align with the business strategy. Have a go at those before we move on. Now to the merit material, the tools and techniques an architect uses to analyze and design. There is a whole family of diagramming approaches here. The Unified Modeling Language, or UML, uses standard notation to model both the structure and the behavior of a system, and it is good for bridging technical and business audiences. Flowcharts show the sequence of steps in a process, simple and accessible but limited for anything complex. Entity relationship diagrams, or ERDs, model data entities and how they relate, which is ideal for database design, while data flow diagrams, DFDs, show how data moves through a system, its inputs, outputs, and stores. Beyond individual diagrams, some approaches capture the wider architecture. Wireframes and prototypes give an early visual of an interface, so stakeholders can react before you have built anything expensive. Archimate and TOGAF provide structured enterprise architecture notation and frameworks that help you line up the business, application, and technology layers of an organization. And BPMN, the Business Process Model and Notation, models business processes in a standard graphical form, which is excellent for spotting inefficiencies and opportunities to improve a process. Like the life cycle models, these tools cut both ways. On the plus side, they build shared understanding across a mixed group of stakeholders. They surface design issues early. They leave you reusable documentation for future changes. And they let you compare design options in a structured way. On the minus side, some notations need real training to read and produce. Overmodeling can slow delivery without adding much value. Diagrams go stale if nobody maintains them. And picking a technique your audience cannot follow rather defeats the point. So, how do you choose? The technique and the tool should fit both the organization and the audience. A simple, informal setting might need nothing more than a flowchart or a wireframe, whereas a complex enterprise context could call for Archimate or TOGAF-based modeling. For the tooling itself, collaborative web-based options like Lucidchart or Diagrams.NetSuite lighter work, while a specialist tool such as Sparks EA supports formal, large-scale enterprise architecture. Whatever you land on, weigh the cost, your team's skills, and how familiar the stakeholders already are with it. Here is a worked example. An architect is designing a new customer portal for a mid-sized company that has limited architecture maturity and only a small project team. Wireframes and prototyping let them validate the interface with users early on, and a simple flowchart communicates the customer journey to non-technical stakeholders. A lightweight tool like Diagrams.net is proportionate to the team's size and budget. Running a full TOGAF-based enterprise architecture exercise here would be using a sledgehammer to crack a nut, far more effort than the situation warrants. Now to the distinction material, change requests. A change request is a normal, expected part of development, but it is never free of consequence. Formally, it is a proposal to alter the scope everyone has already agreed. The moment one arrives, it can pause or slow the current work while it is reviewed, and the team's focus can drift away from the deliverables they had planned. It is worth remembering that not every change request gets approved, and not every approved one is actioned straight away. The real danger comes when change requests are not managed, because the risk then spreads across several dimensions of the project. A steady trickle of small changes leads to scope creep, where the project quietly grows beyond its original boundaries. That in turn may demand extra resources to absorb the additional work, timelines may have to stretch to fit it all in, and costs rise as the extra time, resource, and rework pile up. None of these is dramatic on its own, but together they can quietly derail a project. So, how do you keep change requests under control? A lot of it is proactive expectation setting right from the start. Make it clear to stakeholders that changes may bring extra charges, that they can cause delivery delays, and that a change in one area can knock on to other planned work. If you do not, stakeholders tend to assume changes are free and instant. Scope creep goes unnoticed until deadlines start slipping. Other features get quietly dropped without agreement, and the trust between the team and the stakeholders takes a real knock. When a change request does land, the architect should evaluate it properly before it is approved, weigh it against the original business requirements, and set the benefit of the change against its cost and the delay it introduces. Think about the knock-on effects on other parts of the system, and on the softer things too, team morale, quality, and that fixed deadline. The goal is a documented, evaluated decision, because that written trail protects both the project and the relationship with the stakeholder if the choice is ever questioned later. Let's check your understanding again. Can you name a modeling technique and one advantage it brings? Have a think about why a simple flowchart might be preferred over a formal architecture framework in some situations. Then make sure you can explain what scope creep is and how a change request can lead to it. And finally, how an architect should manage stakeholder expectations around change. Those 4 questions really cover the heart of the merit and distinction material. Before we wrap up, let's consolidate the key terms. The SDLC is the structured sequence of stages used to plan, build, and deliver a system. Agile is an iterative approach that delivers software in short cycles with regular feedback. Scope creep is the uncontrolled expansion of a project beyond what was agreed, and a change request is the formal proposal to alter that agreed scope. A stakeholder is anyone with an interest in or affected by the solution. Process thinking means designing around end-to-end business processes rather than isolated tasks. Enterprise architecture is the structured description of an organization's business, information, and technology, and change management is the structured way we prepare people for new ways of working.